So, last time, I walked through going through and setting up a really basic Docker setup. So, as a refresher, we've got a small little application where we are building kind of a game recommendation site. So, ultimately, the idea will be you'll put in information like what platform you want to play, what genres you like, things like that. And it'll spit back a game that it'll suggest a game to you. There's a game API that we can use to actually kind of pump all that information in and get search results back to. So last time we set up a real basic Docker setup with most of the tooling we need for PHP. So we have a command line PHP container based on 7.2, and then we have a composer container based on that container. So that way all of our extensions flow through. So we can actually run those as kind of our normal tooling instead of having PHP actually installed on your PC or having Composer installed. So for example, like I don't have Composer installed on my PC at all. I do have PHP installed just for make Visual Studio happy, but I don't have Composer installed. But we can run Composer stuff. We got unit tests set up. So we haven't done a whole lot of code yet, but we have a test for our repository. So we can make sure that when we search for something, we're getting back a platform object and making sure that it's got the right data. And for most people, that's the kind of basic stuff you need for, delete that folder. That's all the basic stuff you need for PHP work. Now this doesn't have a web server put into it, and that's going to be part of something we're going to do today. So the goal for today and this next set of videos and stuff is going to be converting our Docker commands over to Docker Compose, because we're starting to get into the point where we need to have multiple types of containers running. So we did a real quick test with command line last time, and we are going to put in a web server and hopefully actually get the database backed this time. So we'll actually look at some database migrations and getting a database set up. So those are at the very least two more containers we need, a web server and a database. And I'd also like to get an asset pipeline put in. Because while I am going to use Bootstrap, most larger applications are probably using some sort of asset pipeline, at least for CSS, if not for CSS and JavaScript. So I'd like to get a pipeline version of Bootstrap actually being put in to show off how you can still use Node stuff to still work on things. So the first thing we're going to want to do is convert all of these Docker run commands into Docker Compose. Now, Docker Compose is basically a config file version of Docker Run. We're going to take all the things we do with Docker Run and we're going to convert them all over into a settings file that we can then kind of distribute to everybody. So right now we're distributing all of our commands via this little helper.sh, and we're not going to get rid of helper.sh. We're just going to convert it a little bit. But we'll go ahead and convert all of the Docker run commands in here to Docker Compose, and we'll have Docker Compose go ahead and also start to use our custom Docker file and custom images and start to have things work out that way. So the first thing we're going to want to do is let's get our web server set up, and we'll start getting that kind of stuff skeleton out. So for Docker Compose, we're going to need a docker-compose.yaml file. This is the config file for Docker Compose. And this is where a lot of people start off, and that's kind of okay, but I really kind of recommend learning how Docker itself works and then moving on to Docker Compose. Because Docker Compose, we're going to translate all those Docker commands into Compose arguments. And that's the easiest way to understand what's going on and what kind of things you can do in here. Now, there's a bunch of different versions of Docker Compose out there, and they are, for the most part, backwards compatible from version 3 on up, I believe, because I don't think version 2 had the newer syntax. But basically, all the main versions should be fairly similar. And for Docker Compose, we actually need to specify what version we're using, because it actually defaults to version 1, which is what most people don't want. Hopefully one day they will change this, but version 1 has a different set of main level keys, and it doesn't work the same way that later versions work. So I usually go with 3.4. You can go with 3.5 or 3.6 if you need some deployment options, and otherwise they're syntactically the same. You can take a 3.4 Docker Compose file, just change the version number and add your deployment stuff if you need to. But the first thing we need to do with Docker Compose is we need to start to define a list of services that we want to use. So we'll do that with a services key. And then inside the services key, we'll actually start to define some services. So the first thing, if we're going to take and convert what we already have, we're going to have a PHP CLI service, and we're going to have a composer service. Now, I'm going to call the one service PHP CLI just because that way, if we have other command lines, which once we get into asset pipelining, we probably will, we don't have to call it, we don't have to, keep everything that same naming convention, because we'll just call composer. But PHP CLI lets us know that this is the container that's specifically designed for PHP CLI. So I'm going to close out. Cancel. Let's close out everything but this one. There we go. Now, if we come back to our helper.sh file, one thing we are doing is every time we need to make a change, we're going to rerun build Docker. So we'll run helper.sh build Docker. That'll go through and rebuild our Docker files. With Docker Compose, it automatically takes care of a lot of stuff like that for us. I'm just going to pop open another window here for some stuff off screen. And we can use this basically to do the same thing where we're going to have a multi-stage config file and have one or Docker. We're going to do the same basic thing where we have a multi-stage Docker file, and then we're also going to use that to specify for our containers. So if we come into here, we can do a build command, and we should be able to do I believe it's context, and we'll do Docker, and then a target, and for PHP CLI, we're going to do base PHP. And that should be good enough for there. So what this is going to say is go into the Docker folder, search for a Docker file, and then inside that Docker file, build to the base PHP. So this should be equivalent to this here. So we'll want the same basic thing for Composer. But instead of base PHP, we're going to go to Composer. We'll save that off. And this should be enough to actually get us going. So if we run a Docker Compose, you know what I didn't do? I didn't install Docker Compose. Let me grab that real quick. That's what I get for reinstalling my operating system. Just a second, because this only takes just on Linux. This is super easy to install. Grab that file. Why did that not download with a... Oh, because they changed that, so now that that's binary, you don't download a thing anymore. Okay. Oh, because that's not chmod. There we go. Okay. So, actually, while we're in this, because this is a better terminal, projects, recommend a game, Docker compose up -d. Now, it's not going to do a whole lot, but what it's going to go through is go through and rebuild our images. Now, the cool thing is, because we were building them before, it's actually going to reuse those layers, because when those layers are generated, they're going to look exactly like the old manual ones that we did. So we can see it's going to go through here real super quick. And if we do a Docker images, we can see now we have a recommend a game com composer and recommend a game com PHP CLI, in addition to the rag CLI and the rag composer that we had before. So we can start to use these now in place of our other thing. So let's hop back over to here. But these really aren't terribly useful so far. The one thing that we can't really do with these is they don't have any mount points associated. So we're going to go ahead and set those up. Now, depending on if you're going to use these for production or not, there's a couple different ways we can set up things like host mount points. Because one downside to Docker Compose is it, for things that are array keys like ports and volumes, they layer on top of each other. You can't reset them. Because Docker Compose allows you to actually, you can stack compose files on top of each other. So you can have a production compose and a dev compose and things like that. But whatever your base one has will just be appended for the most part when it comes to array items. So like with our build key, if our dev environment is different than our production, and they both have build keys, the second one will overwrite the first one because one key will overwrite the other one. Or rather, the context and target will overwrite whatever the context and target of was the parent one. But if you have volumes, which is an array, they just get added, which is kind of annoying. So for this, we're just going to go ahead and set this in the base one because we're just using this for development right now. So we can do volumes, and we're going to say take the current directory and mount this in var www. Now that matches up to what we're doing here. Now the really nice thing is with Docker Compose, all of the pathings can be relative. With the Docker run command, they aren't relative. So in helper.sh, I have to use this pwd kind of shortcut, which actually prints out the working directory for me. I have to use that key to give me the whole directory for that we're sitting in. With Docker Compose, it always assumes everything's going to be relative. You can put in a hard-coded path if you want, but it's always going to basically kind of work with relative pathings. So with the volumes in here, that's going to mount our volume in var ww, which is what we expect here. For right now, we're going to leave off the -u UID. The reason for that is that gets a little bit funky with Docker Compose, so we're just going to not worry about it too much right now. And for this should be about all we need to do. So this one should be mostly converted over. Now, Docker Compose has a Docker run version of itself. So you can do docker-compose run and have it run a container based off your Docker Compose setup. So we're just going to need to modify this to Docker Compose run. We're going to keep the --rm. I think we can keep the -uid in there, but we can get rid of the -ti. Docker run automatically assumes an interactive terminal. Docker Compose run isn't really designed to run things in the background. And then for the container, instead of using an image name like we did before, we're just going to run the container name. So we're going to do composer, and I just realized we're editing the wrong one. but we're going to need to do the same thing down here anyway. So we will go to docker compose run --rm -u and then php CLI. So same idea. We're going to run the command, the php CLI container, instead of directly running from one of our base images. Now the nice thing is we won't need this anymore either. And we'll fix php unit here in a second. But let's just go ahead and kind of make sure that we've got some nice little sanity checks on here. So if I do helper php, it should drop me to an interactive shell because that's the main way that PHP works. If I run helper ssh bin console, which is the little command line script that we wrote last time. Entry point bin console PHP not found. Why not? You exist there. We're mounting you to var www. Let's find out. Docker compose run rm and then php CLI, and we're going to drop into bash. We have nothing mounted. Oh, I know why. No. Oh. Helps if I save that file. Permission denied. Why do we get permission denied? Let's find out. So let's actually drop back in there. Okay, so all of our stuff is in there. Okay, so that all works there. So why does this complain? Because you should not really complain about console.php. Oh, because we got rid of a thing there. There we go. There we go. Okay, awesome. What I had forgotten on there was we still need to specify what command we're running and what, basically what command we're running, because PHP CLI right now still defaults to the normal, whatever the base command is. We can override that, but it's just as simple to override it in the Docker Compose run. So if all of this works, we can take this and we will replace just about all of this. And now we need to deal with the PHP unit container. So with the PHP unit container, there's two ways we could go about this. We could have a dedicated, we could keep it as is and just pass in -e, and it should, in theory, still work. Or we can specify actual environment variables in here as a separate service, which is kind of what I would rather do, because I like to have things, I like to have all of my commands that I use all the time much easier to use, especially if we're not going to use, like, we can not have to use helper.sh as much. So we're going to define a new service called PHP Unit. It's going to be basically the same thing as the CLI, but instead we're going to have an environment set, and we're going to need to steal all of these. So we're going to move these over. And if I remember correctly, it should be this syntax. We'll find out here real quick. Okay, so now this environment is it's gonna pass in all these extra environment variables into a PHP unit container and use them just like we did in helper sh. So we'll get rid of this, and So we're basically going to do the PHP container command, or the regular PHP command. So docker compose run -rm -uid php CLI, and then we're going to specify vendor bin PHP unit and then whatever we want on there. So if we save that, we can do docker compose run, and we'll just do this as a sanity check. rm vendor bin PHP unit. Should be a string. Okay, that's what it is. Some of these are really kind of dumb. So we'll convert this over. Because some of these had, some basic syntax or, similarities between some of these. Okay, I think that should work. No such service vendor bin PHP unit. Whoops. PHP unit. Vendor bin PHP unit. And then, so I didn't have a PHP unit container. So it went through and built that using the PHP CLI one and ran our tests, and that's pretty good. Now, with the environment keys, we really don't want to have those hard-coded in dockercompose.yaml. Realistically, we don't want volumes done either. So before we get too far on this, we should actually clean this up so that anybody can kind of run these. Now, with the environment variables, most of these are going to be the same, but they don't have to be. So we're going to move these into a separate file. Let's see. Let's get the exact name of that file here. Of course, I can't remember what the name of that file is. Environment file is that's what I thought. .env, which is the reason I don't use it, because that conflicts with other stuff. So we're going to do this the way I normally do it. Docker compose.override.yaml. I think it's overrides. Find out. So with the docker compose.yaml, we can actually specify an override file that'll be lumped on top of the normal docker compose.yaml file. So for this, we're going to just copy everything we got. We're going to cut out a bunch of stuff. So for PHP CLI, we are actually going to take this environment section, and we're going to dump that in there. Composer, we're not going to override anything, so we don't need to worry about it. And then for PHP unit, we're just going to pass in environment variables. Now this Docker Compose overrides file, we won't store to the repository. We'll just let this, we'll just let different developers create this. We can specify a dist file and store that, but we don't really want to pass this around because we can have different IP addresses, different passwords and stuff in here depending on the container. So now if we get rid of this, our stuff should still run okay. Okay, awesome. And if we run php CLI -i grep x debug, we should still get all of our settings pop out. Let's see. Xdebug is enabled. IDE key didn't get passed through. Why did that not get passed through? Is it just override? There we go. Remote log temp xdebug, which is what we want. Remote connect back. That's still saying off. Why is that not? Why is that not passing through? Those are the correct environment variables. Oh, because I'm an idiot. That's why. Because I'm using the wrong syntax for get. So let's pop back over to, where's helper.sh? There it is. Because xdebug config is one massive line, not individual ones. Its val type should be an object or an array. Whoops. That was my mistake. There we go. Remote log is getting triggered. There's our xdebug config. And I don't see remote auto start on off. Connect back is on, which is what we want. Okay. Remote enable is on, and then our remote host is there. Okay, so that takes care of that. So for each, for example, coworker, we could specify this as a dist file. So actually, why don't we copy and paste that and make that. They can copy this to their own override file, pass whatever they want, and then that should start. Then they could start using that for their own stuff. So with this, just to make sure we didn't blow anything up. Yep. Okay, good. So now this gets us basically everything in helper.sh containerized. We can now do helper Php unit like before, and that'll run our new Php unit container. Now the next thing we can also do is we could go through and specify a command for this, and that's mostly useful, so we can show that off. So by default, the command for the Php unit container is whatever the base image itself is, because we're not changing that, so it's just php-a to drop us into a thing. We can change the command by default to run something specific. So we should be able to now do docker compose run rm php unit, and now this will automatically run php unit for us. Now the nice thing about doing this is we can actually use this for continuous integration stuff. Because if we look on, if we check to see what the return value of PHP unit is, or of our container, it's actually going to report back something correct. So all of our test passed, we got a 0. If you're not familiar with Unix type stuff, 0 is usually good. That means there's no return code, everything worked properly. If we go into our tests, and we're just going to break this, say PlayStation 24, we run PHP unit, it gets a failure, which is fine. We'll notice now we're getting a 1 back, which means there's a failure. Most continuous integration systems like Jenkins and GitLab and all those stuff, you can actually test to make sure that the commands work okay. So we've containerized a command we use all the time. Now, I'm going to leave helper sh the same way. So if I do helper sh, it should continue to work just fine. Yep. The reason for that is the Docker Compose is going to be good for automated systems. It's just going to run vendor bin PHP unit, no extra commands. It's going to run everything that we have. If I have a lot of tests and some of the tests take a little bit, a normal test suite with a couple hundred tests is probably going to take 5-10 seconds to run, which is not a huge amount of time, but it is a decently large amount of time, especially when you're constantly running them. So you can do things like -- filter with our helper script. What's the name of our one test? Test find platform. So we can do filter test platform through helper to run the one test, and then the container through Docker Compose is going to just automatically run vendor bin PHP unit and be done with it. So that's the conversion of those regular Docker run commands to Docker Composer and Docker Compose rather, and then actually getting them fixed over for our helper.sh script so that we can do that. Now the next thing we are going to want to do is actually start to get some more orchestration things going on. So let's get a web server put in. So we're just going to call this web server. And we're going to need to do a little bit of work in our Docker file. Because with the stock PHP containers, getting Apache set up in here is more work than I want to do. If you're not using the stock PHP containers and you're just using Ubuntu or CentOS and stuff, you can have your Apache container based off your PHP container. But we're not going to do that. We're going to cheat a little bit knowing how these work. So we're going to take PHP 7.2 PHP and we're actually going to do Apache. Now you can do Nginx, doesn't matter. I'm old and set in my ways, so I like Apache and I'm going to use it. The only difference between what I'm going to do here versus Nginx is you're going to need an Nginx container and a PHP FPM container. But functionally, the idea would be the same. You would just use the FPM container as your base PHP instead of anything else. So we're going to use PHP Apache as base PHP. We're going to copy our run command. And otherwise, we're going to leave this the same. Now, PHP CLI, we're going to change this to PHP CLI. And then we're going to change from base PHP to PHP CLI. And we're going to change this one to base PHP. And get rid of our run command. And we're gonna do entry point PHP and then command. I believe we should be able to get away with just that. CMD. There we go. Not command. Okay, so what we're doing is we're going to change our system to, instead of working from the PHP CLI as our base, we're going to use PHP 7.2 Apache as our base. We can do that because PHP 7.2 Apache has the PHP executable inside of it, so we can use that in place of PHP CLI. Now, our CLI container is going to have extra stuff for Apache, but for this, it's really kind of worth the convenience instead of having to start everything from scratch. Now, if you're doing production containers, again, you probably are going to be building from something like a stock Ubuntu or Alpine or CentOS, so you can kind of build stuff up a little bit better. But using the stock PHP containers, I find this is usually the easiest thing. So base PHP now is going to come from Apache. And then we're going to save this off as PHP CLI now. We're still going to change the workdir. We don't really have to, but I'm just going to make sure that that's still specified. Now, what we are going to do is change how this container works. So the default, change this up here. The default web server container is going to automatically start up Apache and start to work from there. We don't want that to happen on the command line one. So we're going to change the entry point, which is currently set to run Apache. We're going to change that to PHP. And then the command that's going to be the default, if we don't do anything else, is going to be dash. And actually, if we're going to keep this the same, this should actually be dash A. So now if we just run if we just run PHP CLI, we should get dropped into a terminal at just, the really crappy REPL that PHP has. We should get dropped straight into that. And then Composer is still going to build off PHP CLI as before, so that's all fine. And because this is all based off Apache, off the Apache image, we're going to have all of our extensions flow through to all three of these. So that should be all we need to do there. Then here we're going to do PHP CLI, and PHP Unit is going to switch to PHP CLI. Composer is going to stay the same. And we're going to grab some extra stuff here. So we're going to do the same basic thing, but we're going to call this base PHP. So it's going to look in Docker, target the base PHP, and then we're still going to mount the same volumes. So if we did this correctly, if we do a docker compose build, everything should basically work. So let this build, and then we should be basically kind of good to go with this. And this doesn't usually take too long to build. Okay, Composer's doing its thing, look like. Oh, no, there's Composer. Okay, so that should have all worked. Now, just as a sanity check, we should be able to still run PHP Unit. Yes, awesome. Now, this hasn't done a whole lot for us with the web server. So, the next thing we need to be able to do is actually run the web server itself. For this Docker Compose build just built the images. They're not really doing anything at all yet. This is another place where, depending on how you want to, like exactly what you're using Docker for, you can move these things around. Because we need to be able to actually access the container itself. I believe I'm doing that in the correct order. So we can specify ports to be passed through to the host. By default, the container is listing on port 80, but you and I and really anything that's useful doesn't know what the IP of that container is. Docker does. We can do a command to actually get that IP, but that's only useful on Linux. If you're running Mac OS or Windows, the IP that Docker says is the container is not a reachable IP for you. I think Docker for Mac does some weird translation stuff to try to make it fake and make it look like it's running locally, but it doesn't. The IP that's assigned to the container is usable really only inside the virtual machine. So we need to open up port 80, some sort of port on the host to be able to access it. So we're going to tell it to open up port 8080 on the host, and that's going to map back to port 80 on the container. Now, I'm putting it in the Docker Compose file, but this could potentially run us into a problem down the road if you're using these things for production, the Docker files for Docker Compose files for production. The reason for that is with this, we are assigning port 8080 to this container. That in and of itself is not bad, and it's good for development, but most users aren't going to know to go to port 8080 to visit your website. So you probably want to use port 80. Well, port 80, if we're going to try to stack things, if we go to the override file, let's say, and we do web server ports 8080, one might expect this to override. One might expect this port 8080 to override this port 8080. It doesn't. It'll actually stack. So you'll actually open port 8080 and 80 on the host. So what most of the time what you want to do is you'll want to structure Docker Compose to have your production settings, which in our case would basically mean don't put ports here, and don't put volumes, and then move those off to another file. Since I'm mostly worried about development for right now, I'm just going to stick them in here, but that is something to keep in mind. So we're going to come back over to here, and we're going to delete that before too long. So that is just something to keep in mind. Now, if everything is good, we should be able to do Docker Compose up-d. And it's going to go through and rebuild the couple containers because we did technically change our Docker file. And I've already got port 8080 allocated. Why? I do. Because I was testing things earlier. Actually, since we're in here, Docker Compose up-d. Okay, so that should start up. It's going to starting a composer container, which isn't going to do anything much for us. A CLI container, which isn't going to do anything for us. PHP unit, which is actually going to run our unit tests in the background, which we don't really care about right now. And should start the web server. If I do a Docker Compose PS, we should see the only thing that is currently running is the web server, which makes sense. The other three are actually command line apps, so we don't need them to do anything. And we can see this is using 8080 to 80. So if I pull over a Firefox window and I go to localhost 8080, we get forbidden, which is totally fine. We don't have anything actually mounted to the system right now. So that actually gets us up and running for the web server. So now we actually have a whole web server working. If we go into HTML, video index.php, permission writing. Oh, because I didn't make that beforehand. So I didn't make this folder beforehand, and we didn't run the web server as our UID, so that wrote it as root. So we're going to do sudo chown HTML, my user. Let's try that again. New file, index.php. There we go. And if we refresh, we get our PHP info. So web server is now working. It's hooked up through our Docker Compose. It's being used as the basis for all of our other containers. So we now actually have this able to be used and work from there. So again, a couple things to keep in mind with Docker Compose is things like ports and volumes. Whenever you override them, they stack. They don't actually override. So if I change this pathing here in Docker Compose override, it'll just stack on top of here. It will not actually remove this. And as far as I know, there's not a way to actually tell it to do that. It will just always stack. Individual keys will override. So context could be overridden through override. Target could be overridden, but we're not doing that in our case. And things like environment variables, you should always put in the override file. So here we've got our xdebug. That way it'll actually, we can let individual people specify these, especially things like remote host, on their own specific machine and not break anything. We may want to move ports over there or volumes, but for development and situations where you're not actually going to necessarily use these compose files to deploy with, hard coding some of these Devi type stuff in Docker Compose is usually just fine. So now that we have that set up, we can actually be able to start working a little bit on the application itself. So the first thing I think I want to do is I want to look at actually getting a database properly set up. So we have this platform repository. Should be able to control click. There we go. Right now, it's just taking in, it just has a raw data store. There's nothing really here. So we actually should probably back this to a real database. So the first thing we probably want to have is an actual database behind it. So let's pop back over to database, Docker Compose. Now we have a web server. Now we're going to need a database. So we're just going to call this database. And for this, I'm not actually going to add this to the Docker file for all of our other stuff, because most of the time, the database itself should run fairly stock. We're really not going to modify it that often. And I'm going to be totally honest, you should not be containerizing your database in production anyway. So for this, we're just going to use a stock image. This gets us into an interesting problem. We could use something like MySQL or Postgres or whatever you want. And you can really kind of choose whatever you want. But I'm going to use MySQL because, again, I'm stuck in my ways and it works for just about everything. So if we come here and search for MySQL, we're going to run into an interesting problem. And this is a problem that I don't know if most PHP developers, and I don't know if most developers using Docker kind of realize. Whenever you see the word official in here, all this means is that Docker actually built the image. These don't necessarily come from the actual company or developer that does these. For example, as far as I know, the PHP images are not actually distributed by the internals team. Someone on Docker actually maintains that. And they've been around for a really long time. This MySQL container is not actually supplied by Oracle. This is a fairly old image that is just maintained by the Docker team. If you want the official Oracle one, you have to go to MySQL/MySQL server. This is actually maintained by the MySQL team at Oracle. So one thing to keep in mind, official just means official in the eyes of Docker, does not mean it actually came from an official source. That being said, anything that's just public, you need to see where they're coming from and whether or not you want to trust those people. So in the case of MySQL, this namespace is owned by Oracle, so I'm going to trust anything that really kind of comes from there. Same thing with the cluster. This is actually maintained by Oracle. MariaDB, as far as I know, this is not actually put out by MariaDB. This is put out by Docker, and it's built the way they think it is, or they think it should be. CenturyLink MySQL is just operated by the CenturyLink team. You know, they have a bunch of containers because they've been using Docker for a really long time, but this is not official in any way, even though it's, from CenturyLink. So we're going to use the MySQL image. And this mostly works as a drop-in replacement for the regular MySQL image. The only big difference is this does not allow root remote root connections by default, where the other one does. So that, in a way, this is a more sane setup. So we're going to use the MySQL server image. Now, with Docker containers, data is ephemeral. Because the idea is you should be able to skeleton up a container from an image, use it for whatever you want, and then dump it. You're not really worried about the data that's inside there. So in our case, we actually do kind of want to preserve our data from run to run, because we may be destroying containers left and right, or if we ever need to upgrade databases, we want to keep our data around. So we could use a volume like this and just have like a data directory in here that stores it. That's pretty dirty though, because you're never really going to want to touch that stuff anyway. You can specify storage containers inside Docker itself and have them use those. So the Docker Compose file has a way to do this, and of course it immediately escapes me right now, so let me get the come on. There we go, volumes. So we can specify a volume, and we're just going to call this MySQL data. So what we can now do is tell the system, or tell Docker Compose, volumes, we're going to mount MySQL data into var lib MySQL. We can create kind of carved out sections on our computer that will house data that will be persistent across multiple versions of the containers. So really all we need to do is give it a name. You can specify like if it's an NFS mount or a GlusterFS mount or things like that, because the Docker volume system is actually technically plug and play or pluggable. But we're just going to store it somewhere on our system, and I really don't care what it is, because I'm never going to mount these files in my own local database server. So we're going to create a named volume, and we're going to use that named volume here. So this MySQL-data equates to this up here. This volume here will be created somewhere on my computer under var lib docker. And then that's going to stick var lib MySQL inside there. And if I do a Docker Compose up, that should pull the MySQL container. And then it should boot it here in just a second. So we'll give this just a moment to pull down. And yeah, there it is. Docker Compose PS. We can see it is up and running, and web server's continuing to run. So now this, the database takes a few seconds to boot up. So we're going to go ahead and just kind of let that boot up here for a second. Okay, it's up and it's healthy, which means we should be able to access it. Now, one thing we didn't do, which is something we're going to have to kind of do now, is we have no connection information for this. There is a root password stored in the logs for this, but that's not really helpful to us for anything. So let's do a Docker Compose stop. And we're going to do a Docker Compose RM. We're going to delete all those. Now, one thing that Docker Compose does not do is it does not delete volumes. So we just destroyed all the containers, but all the data inside of our MySQL server is still there, which is good. But we're going to want to actually set up some users, so we need to destroy that too. So I'm going to do Docker volumes ls, Docker volume ls, and here we have a volume name. So we're going to do docker volume rm that name, and we're going to completely nuke that that volume. So now the MySQL container will actually let you specify some environment variables to set this up. And we can actually steal that, I believe, from the other one, because I don't think it says in here. Nope. So I know we can get, like I said, it's mostly a drop-in replacement for this. So we can grab a couple things here. We're going to do an environment. And then we are going to want a MySQL database equals, we're just going to call this appdb. MySQL user equals appdb. And MySQL password equals, we're just going to call it password for right now. Super secure, I know. But for development, we could do that. Now, again, the other thing we can do is we can move this to Docker Compose override, which is not a bad idea. Or having specific values in, like not having an environment variable in here, and then using specific Docker Compose files for production and development. So we're just going to throw those in there. And we'll do another Docker Compose up-d. And it's going to go through and rebuild. Docker Compose logs dash follow dash tail 5 database. There we go. So if we watch the logs here, it's going to go through and build everything. And I think X plugin is ready for connection, so that should be good. Okay, so if we do a Docker Compose PS, we can see it's up and healthy, and that's all good. So I'm going to drop over to here real quick. So now to test to make sure all of that stuff worked, let's do a Docker Compose. Now I'm going to use exec. Exec works like the Docker exec. It'll drop you into a running container, but we can use the service names instead of the long convoluted names that Docker is using for each of these containers. So we'll do database bash. We'll get a bash script or bash prompt. appdb -p, and we'll specify our password. Whoops. Awesome. So now our appdb user was created. It used the password that we specified. We do show databases. We have appdb. Use appdb. Okay, no tables because we haven't created anything yet. So now we've actually got the database set up, and it's using the environment variables we specified here. And now we can actually start to worry about populating the database with some information. So with the database, we could go through and we could just start keeping SQL files and try to keep all that in hand. But there's a lot of useful migration scripts out there that we can use. The one that I use most of the time is Fing, if I'm not using something like Symfony. Fing is a really nice migration script. It's really easy to use and allows you to build the migration scripts in PHP and not only build stuff, but also have program logic if you need to do data manipulation. So we can go through and actually install that. So let's go over to Packagist, Finks, and should be Rob Morgan Finks. Thought that... Oh, right there. Looking for that. Composer. Exit out of there. So we'll do helper, composer require Rob Morgan Finks. Command composer is not defined. Why is that not defined? What did we do wrong? From PHP CLI as composer. Those should override. Huh, let's find out. Whoops. Oh, I must have... What did I do wrong in helper? Let's find out. Oh, because that has specified. Failed to open stream, permission denied. Why is that permission denied? Composer.json's owned by me. Composer.lock is owned by me. Oh, because we mounted this wrong. Composer needs to have a volume. Helps if we, put the file in place that we want it to work on. Okay, so Composer is going to install this. So we'll give this just a moment. While Composer takes its sweet time downloading everything. Okay, so now we have things installed. And we can now start to set up tooling for that as well, just like we have PHP Unit and we have Composer. So if we come back to that one. So we've got PHP Unit. And so let's go through and we're going to do a Sphinx service, or a Finks service rather. And we're going to change this around a little bit. We're going to do entry point is Finks. And by default, the command is going to be hyphen. And we're just going to use the target CLI because there's really nothing in here we have to manually override. We'll just use a CLI. So if we do a docker compose run rm Finks, we can see this automatically runs and we are good. So it built the Sphinx container for us, or Sphinx image rather. And then just running Finks allows that to work. So if we do an init. Awesome. So here's where we get a slight difference between what command and what entry point does. For PHP Unit, we specified just a command, and this is what's always going to run if we don't specify anything extra. And that's because I want this to be a little bit more easily extendable in case we need to have this run some other command, just for testing. For Finks, what we're going to say is whenever you run the Finks container, always run the Finks command. No matter what the user specifies, run the Finks command. Anything the user specify is going to be options for the Finks command. So we're going to default that to just dash, just to make sure that nothing actually runs. So it's going to run vendor-bin-finks and then a hyphen, which in Unix most of the time just tells it that, like this is the end of the, anything after this are just additional commands. So whenever we run Finks down here under Docker Compose, it's going to just take anything we have and layer it on top of there, replacing the command. So let's pop up back over to here. And we're going to change this to Finks. And we should be able to do any sort of args we want. Now I'll pop back over here so it's a little bit easier to see. Helper, Finks, should get our output. Now, with this is a pretty bog standard database migration script. We have an init, which will give us a blank configuration file, which we'll edit here in a minute. We can migrate things, we can roll things back, we can check what the current status is, we can list what these commands are, and we can actually generate seeders for all the database. So init will give us a base config script, which should be right here. Now this is something else we don't really need to specify. So we're going to not ship a finks.xml. And while we're in here, we're not going to ship a docker compose.override.yaml. Save those off. Okay, that looks about right. So we come back over here to Sphinx, or to the finks.yaml. This is all the config for Finks itself. Now, one thing I find slightly annoying is you can't. It's kind of hard to, because this is a YAML file, to pull things from other files. So if we have a .m file storing all of our configuration data, it's harder to pull things in here. So you kind of got to copy and paste some things. But we're going to go ahead and modify this development section. And the name is going to be appdb. The username is going to be appdb. And the password is going to be password. Now, with Docker Compose and Docker itself, every process effectively runs as a separate container. So we are going to want to point the host, not to localhost, because the Finks container is only going to be running Finks. It's not going to be running MySQL. We need to point it at the database server. With Docker Compose, we get a couple shortcuts because it'll actually do what's called service discovery. We can specify a service name, like database, and Docker will automatically route network traffic to the appropriate container. So in Finks, we can specify use a service called database, and it will route it to this container. So we're going to do just that. Database. And we've got permissions problems again. Because I ran that by hand, I didn't run it with the UID. That's my bad. Okay, so that should now be saved. So now if we come back to here, we can run status. And it should complain that, yeah, there's no available migrations. So it didn't blow up, which means it connected to our database, checked, and didn't see anything for us to do. So let's create we're going to create a migration that's, we also forgot to, I'll do this data/data. So the one thing we need to do is we need to specify where our migration files are actually kept. So by default they're in /db. I like to keep all my data in one folder, whether it's data or other kind of configure-ish kind of stuff. So we're going to create a data folder, and we're going to do a new folder called db, and another folder called migrations. So let's pop back over to here. Okay, that created the file. Now this one has the property user. Okay, so I can manually edit that. So we can see we've got one just called platform. And here we can actually now write our migrations. So if we come over to here, we can pop over to the actual Finks website. And we can go to docs. And from here, we could just follow the docs for actually creating a migration. So let's go to create a new migration. And we're just going to use the change method. And this is the basic kind of syntax. So we're just going to copy that, paste that in here. We're going to create a new database called platform. By default, all of the columns are going to have an ID column unless you specify them otherwise. I'm a big fan of using natural keys. So for example, our platform should actually, the platform is the main key, but I'm just going to let it kind of use the IDs and the names and stuff. So right now we're just going to have a name. That's going to be a string. And that should be it. It's going to create a database, name, string. So Sphinx, video status now. We don't have a MySQL extension, and that's because we haven't installed one. So let's pop back over to our Docker file. So now we've got Peckle install, and we've got Docker ext enable. So we're actually going to also do a Docker php ext install PDO MySQL. So now this will actually go through and install the PDO MySQL extension for PHP. What we can also do, I think, since we're technically using MySQL 8, I actually don't know if this will work, but we can actually give it a try. Actually, no, offhand, that's going to break a couple other things I want to do, so we're going to leave that off. So we're just going to install PDO MySQL. We'll use the old driver, which is still fine. It's not going to break anything. We're just not going to get some of the new Fluent stuff. So we'll do PDO MySQL xdebug. Docker compose build. This is going to go through and it's going to set up. It's going to go through and install everything again, but at this time it's going to go through and install PDO MySQL, and then that'll be available to all of our containers: Finks, PHP Unit, Composer, the command line application, all of those. So we'll give this a second and let this build. And this will take a little bit longer because the MySQL extension is a little bit bigger than xdebug. So we'll just let this run. Yep, so now we did xdebug, so now this is installing, or this is compiling MySQL. Okay, that's done, and it's building all of our other stuff, so Composer's running now. Okay, Composer's installed. Now all the other stuff is working. Okay. So now if we run status, we should connect. No. The server request authentication method unknown to client. And I think that is actually a MySQL problem. Let's see, because I always forget this. If you use the old driver with MySQL 8, you got to fix some things. Let me find where that is. Oh, that's right. A bunch of this changed. So what we're going to do is we're just going to cheat a little bit. MySQL Server 5.7. Save that off. Let's actually bring us up to a nice little thing that we can do to set some stuff up. Let's RM, so we can easily delete all that. Docker volume RM. Delete out the MySQL container. So now one thing we can also do is do a couple little nice things here to make having automatic things happen for us nice. So we can do a depends on database. So we can say Finks depends on the database. Now, with Docker Compose, all the stuff is going to try to run as much as possible. But Finks, we can actually do this, migrate. We can tell Finks, when you automatically run, if you just run Finks by itself, try to migrate. Now, migrate's not going to work till the database is ready. So doing depends on database should have this kick on after the database container comes up, and then it's automatically going to run our migrate stuff. So if I did this correctly, it's going to pull down 5.7 instead of 8. Because I always forget MySQL requires a new, So here we can see that Composer ran, database started, and then Finks kind of sat there for a second. Whoops, didn't mean to do that. Meant to do a PS. So this is saying health starting. Let's see what Finks is saying. Actually looks like it did migrate, so that was okay. Yep, okay, so I guess that actually, yeah, so that it actually didn't have anything to do. So when we did the Docker Compose up, our database migration actually automatically upgraded us to whatever we needed it to be, which is really useful from a developer standpoint, because that way, whenever we check out code and we just bring the whole system up, it's going to automatically pull all that up. Now, if we want to take that a step further, we could say Composer could have a command automatically to run install. So we could do that, and just whenever you do Docker Compose up, it automatically builds the application as best as it possibly can. So database comes up, Composer runs, all your migrations run, and those are all good to go. But as it is right now, we can do a Docker Compose exec database bash. So use appdb, not shop tables, show tables. So there is our platform table, really tiny, not a whole lot, but we could actually start to put some information in there. But that gets us our database migrations, and they should start to run automatically no matter what you do. So we're starting to get a lot of this stuff kind of skeletoned out, and using just a couple of basic containers, we can start to get all of our tooling and the things we do all the time starting to be set up. So now the next thing, which is a little bit more, it's outside what PHP itself does, but it's something that a lot of people have to actually do, is asset pipelines, which let's see. We've been going about an hour and a half so far. Yeah, we'll see how far we can get in this. So with asset pipelines, the idea is we're going to have CSS or JavaScript or both. And when those things change, we want to do things to those files. Most of the time with JavaScript, we're going to what's called uglify it, where it's going to go through and it's going to compact it down, remove a bunch of white space, rename variables to something much shorter. So that way the payload's much smaller on the line. With CSS, about the only thing you can do is just kind of remove a bunch of the white space. But with CSS, we may have things like we have Sass scripts, and those are going to get compiled, transpiled down into CSS. Same thing with JavaScript. We may have ES6 script or TypeScript stuff that's going to get transpiled down into just, low-level JavaScript code. So for this, we're not going to have any complicated JavaScript yet. We'll get to that later. But I would like to actually get some HTML stuff set up. So taking the ideas that we've got here so far, we're going to go ahead and introduce asset pipelines. And I know there's a couple in PHP, but really, I'm not super thrilled with most of them. There is stuff like Ascetic that work pretty well. But at the same time, most of this, we're going to be using JavaScript for bigger things and Sass for bigger things anyway. So we might as well do those in those languages as opposed to something like PHP. We can still containerize them all in Docker, but I don't see a real big need to go through and do that stuff in a PHP level kind of thing, because I think the tooling in Node is arguably better. So, pull up my notes here. The first thing we're going to want to do, because most of the stuff is Node.js based, is actually set up a Node.js container. So let's go through, and we're going to create a new section in our Docker file. I'm going to grab a header, and we're going to call this Node.js container. Now, using the multi-stage builds, we can have one single Docker file that handles all of our image configuration. Now, they can be layered, but then you can have other containers that don't reference anything else. So we're going to do from node 11 as base Node.js. Now this is going to just pull from node 11, has nothing to do with our PHP containers at all, and that's perfectly fine. We are going to set a worker of var www just to keep everything in line, with the single exception of our composer thing. And that should be all we really need to do out of the box. One thing we will want for CSS, to make things nice for CSS, is there are a lot of packages that want to be installed globally, and usually what I do, and I am not a front-end developer, so I mostly just do this as best as I can because I'm a back-end developer. The things that Node wants to be installed globally, I just install straight in the container, mostly because those things aren't generally controlled by the package.json and package.lock. They're just installed, and the system assumes that they're there. There are things like NVM and stuff like that, which you should probably use. But for most of the containers, we're containerizing them all in the container anyway. I'm not necessarily worried about having multiple versions of the same thing installed, because my application is only going to want to use one version of Node. So in this case, we're going to use Node 11. If we're using Node 6 or 10 or whatever for another application, those are going to be contained all in their own stuff too. So we're going to go ahead and do a run. And then one package I know we are going to need is going to be clean CSS CLI. So we're going to do npm install global clean CSS CLI. So now this should go through and install that. And then anything that we need to be global, we'll just add to the Docker file. So that's pretty easy to handle. Anything that's application specific, we'll just install using regular npm. I know there's yarn. I use npm Yarn is probably better. So if we do I'll hop out of our database here. Docker compose build. Everything should build pretty quick. And somewhere in here, oh, whoops. Let's actually get a container too. So let's get a base. We're going to grab PHP CLI. And we're going to call this node CLI. Actually, we're going to call this NPM because technically different commands, the node container has NPM, yarn, and node. So those are technically all three different commands. So we're going to call this base node.js. We're going to mount that to var ww. And our entry point for NPM is going to be NPM. And our command by default is just going to be dash. So now NPM should be available as a container. So let's actually rebuild that. Because we'll notice Docker Compose build only uses what's in the Docker Compose YAML file. Since we didn't have it specified, it's not going to just automatically build stuff. It's going to ignore things it doesn't know about. And let's head back over to here. Let's get a npm command. So now we should be able to do helper npm. Yes, awesome. So that automatically runs our npm, and we can go from there. Now there's a couple. We're going to do -i. And whether or not these are... Whoops. Why did you not... Is it I? It is. Whether or not these are the best packages, I don't know. They are just some of the packages that I've used in the past. And my music stopped. Did we actually get all the way through that playlist? Nope, it just paused. So I don't know if these are the best modules to use or not. These are just the ones I've used in the past, and that's what I'm going to continue to use. So Chowkidar is one that is used for running some commands that we'll do. And then we're going to get some CSS stuff in here and some Sass stuff. So auto prefixer and post CSS allows us to do some CSS stuff. And whoops. Actually going to need node Sass, I believe it is, to no, but check it out. Chowkidar Sass pulled that. Should have pulled that in. Did install that, right? Yep. Okay. So pull my other tab back up here. Now, I'm not going to get too much into the node stuff. And we need to add that to our git ignore file. Because we don't ever want to ship node modules. But now we have our package.lock. And why don't I see... Refresh. Why don't we have a package.json? Oh, we didn't actually create a package.json. Oops. Let's see, and that is npm init. So let's actually rerun. Whoops, cancel. This is one thing I hate about npm. Just cancel. Save. It allowed me to install these things without telling me I didn't have a package.json file, because I skipped a step in my notes. I know it generated a lock file, but that's still annoying. So let this go through and reinstall again. Thankfully, these don't take very long. There we go. Now, if we come back here, I now have package.json. So we've got our auto prefixer, CLI, all that fun stuff. Now, the other thing, we'll get to that in a minute. So, with this, we should be able to now compile Sass scripts and have them automatically dumped out, and then we can have them dump into our HTML directory. So let's grab a bunch of npm scripts. And again, I don't know if npm scripts is still the way to do this or not, but it is just the way that I do that. So we're going to grab, oops. Copy this again. There we go. So now there's a whole bunch of junk going on in here. And again, I don't want to get into the fine details of exactly what is going on with this asset pipeline. But suffice to say, we're going to have a CSS folder. And in there's going to be all of our stuff. So we're going to create a new file. We're going to call this rag.scss. This is going to have our custom Sass files. So that is going to compile right here. It's going to run node Sass, and then it's going to take those and dump those into a dist CSS file or folder. So we're going to create that file or that folder. And we're going to throw a .git keep file in there just to make sure we can dump that into Git. Let's go back to package.json. So what happens is anything in this file, this folder, in the CSS directory, we're going to use that as the basis for actually generating distributable built CSS files. Post CSS is going to go through dist CSS, which is the built stuff from Sass, and it's going to go through an auto prefix stuff. The idea there is it's going to put all the browser prefixes in there. And then the other thing we're going to want is CSS build. That's going to take everything in the dist.css folder after it's come through auto prefixer. That's going to generate a rag.css, which we'll be able to use in our actual files. All of that can be run with Sass build. And I think, actually, I take that back. We need to do 2 steps on there, which I'll need to fix. But then we can also have a watch script in here, which is going to go through, and whenever anything changes inside of our CSS directory, it's going to go through, build that stuff, and magic happens because JavaScript is nothing but magic. So we have our npm file, our npm container. We should be able to run helper npm run Sass watch, and it should boot up. Missing script. Did I not save the file? No, I didn't. There we go. Okay, so now it's watching our CSS directory. If I come into rag.css and let's just do HTML, background color red, it's going to blow up. Shell environment variable not set. Oh, okay. This is actually a problem with Docker itself. So even though it's technically running bash, the stuff isn't running in bash. So let's go to the Docker file. I'm going to do env shell equals bash. Whoops, not base, bash. So this way, our npm scripts know exactly what shell that they can actually run in. We know bash is installed, so we're going to use bash. So let's do a docker compose build to rebuild that. And now this time it should work. So let's change our... Where'd my stats file go? Too many things are open. Change this to blue just to change it. There we go. So now I edited that file and it blew up what... Oh, because I don't have a public page. So let's also get public CSS. And actually we need to change that to HTML folder CSS. So it's going to output to HTML CSS. Restart the watcher. Change this back to red. Save. So now it should build fine with all the directories made. Okay. So the Sass ran, compiled, ran all of our auto prefixers, then turned around, ran clean CSS to generate a tiny file. If I look in HTML CSS, we have a rag CSS with everything all nice and done. So that actually lets us get a really basic asset pipeline set up pretty quickly by just using Node and a couple different Docker Compose settings to actually get npm to work by default. And now you can actually have all of your build stuff in here. So you can do things like browser sync, which we'll show here in just a second, to go through and actually reload this stuff on demand whenever they change. So while I'm in here, we're going to do a get keep. Now we have index.php. We're just going to rename this to index.html. And let's just make a really ugly HTML page. Head. Link rel equals style. Sheet. href equals, we're just going to do css rag.css. Okay, so if we go to, if we reload this, we're going to get our little hello world thing. Now, if I come back to here and we change this to blue, save that, we'll notice in the background this reloads, which is fine. That's what we want it to do, or it actually rebuilds. And if I come back to here, refresh, we get blue. And I'm sure that looks wonderful on the stream. But so this gets us, our pipeline is working. But let's actually take that a step further and get actually some live reloading going on. So if we come back to our Docker file, we can add browser sync to our Docker file. And we can use browser sync to actually go through and reload the page for us whenever we edit these files. So we're going to stop this, Docker compose build. And we'll let that build in the background. And we're going to grab a couple extra lines here. And we're going to augment our package JSON script just a little tiny bit. Whoops. There we go. So what we're going to do is we're going to have a reload command. it's going to run browser sync. It's going to start it. It's going to tell it to watch the public directory. So anytime anything comes in the public directory or changes in the public directory, it's going to reload the files. It's going to no notify just means it's not going to tell us about anything like connections. Host, we can actually call web server, because just like with the MySQL container, or just like with the Finks container, we can reference other containers by their service name. So our web server is called web server. So we can actually set the host to web server. I'm sorry. Host is what we want to listen on. So we're going to listen on all IPs. Listen on port 9000. Proxy, is what we want to proxy. So it's going to take any requests that come through, and instead of serving them themselves, it's going to actually proxy them back to another machine and let it handle it. So we're going to proxy this to web server. We're not going to proxy this to web server 8080 or localhost 8080, because that only exists on the host, and the containers don't know anything about the host. And we're going to augment our watch command. It's going to run npm run all, and we're actually going to run SAS watch and reload at the same time. So SAS watch will watch for our files that change. Reload will watch for files that change in public. So whenever we edit a SAS file, SAS watch should catch it, run through its build process, ultimately dump out something in public in HTML. Let's change that there. In HTML, and then that should cause the browser to reload. So our stuff's finished being built. So now we're just going to call run SAS watch. We should notice the SAS stuff kick up. Browser sync has started. And if we go to localhost 9000, nothing will show up because we haven't actually opened that port. And that's okay. We're, purposely didn't do that to show. Whenever we open up ports, we need to actually specify that they are open back to the host. So let's go to dockercompose.yaml. We're going to go ahead and do ports. And we'll just do 9000 to 9000. Save that off. Close this. Restart it. Because this is a new container, it's going to open up port 9000. So we can see here we can go to localhost 9000, or even though this says 000, it's not actually going to work. So we'll go to localhost 9000 this time. Maybe. Why didn't you open up? Did I not save my file? Nope. Port 9000. What did we do wrong here? Just to make sure those restart. Okay, npm should be working. Waiting on port 9000. Why is that not working? npm run watch is running. It has no ports open. Why do you not have any ports open? Why is that not opening? Because it's the npm container. And that should be doing 9000 to 9000. Just close this file and make sure it's actually opening. Writing that properly. Yeah, that's correct. Did I break something in helper? Closed helper. npm Docker Compose run npm args. That's all actually fine. Let's run this the long way. Docker Compose run rm npm run watch. Oops. Why is that not picking up the ports? That lines up there. We're running entry point npm. Huh. Just cheat and do it that way. Shouldn't need to do that. Whoops. Cancel that. Now that has to point out. I understand why it's not picking up from the Docker Compose, because that should be fine. So I'll check that later. But so here if we've got hello world. Let's shrink this down a little bit. Let's pop this back open. So now we get back to what we're doing here. If we do red, save, it's going to go through the back. And we get an automatic reload. So now we've got browser sync working. I don't know why the ports aren't working. I'll get that figured out. But we now have live reload. So if we could do the same thing with JavaScript, it'll automatically run our JavaScript and all that stuff. But that's, for the most part, that's the pipeline I use. CSS stuff. You could throw the JavaScript stuff in there, and then browser sync also works. So that gets a pretty standard asset pipeline setup with everything. So hopefully this is useful to most people. I think this really starts to get much more of the web development stuff put in, and kind of the niceties that we take for granted with web development. But also the big thing is it frees up having to have your machine set up a specific way, so you can work on multiple different types of projects and be able to change between them, no matter what version of PHP they're on, or Node, or anything else, and you still get the standard tools that you want. And I can take all of these same settings, give these to a coworker, and they should be able to bring the stuff up and have it automatically kind of work too. And you can augment this with stuff like Webpack, different live reloaders, transpilers, all that stuff, by just doing the normal stuff you would do. NPM scripts are, I know at least at one point were a way of doing this kind of stuff. It's still the way I tend to do it, as opposed to using like gulp and things, because I'm not doing anything usually terribly complicated. So, but hopefully this helps. This gives you a lot more idea of what you can actually do with Docker Compose.